When I was chief scientific advisor, I was working with the CSA from Bayes, who was looking at the future energy strategy for the UK. And they could see hydrogen being used for things like heating homes and cooking, for large industrial processes, and for agriculture, and a number of other sectors as well. And that made it interesting for transport, because when hydrogen had been looked at individually for transport over the last 30, 40 years, people have been looking at it for one use case, one application, and the like. And the numbers in terms of generation of hydrogen, distribution of hydrogen, burning it, or of hydrogen, or using it in fuel cells, it didn't stack up. But once you realize that other sectors within government were interested in hydrogen, then looking at it from transport again, I think was really, really important. At the time, within the DFT, there was an absolute laser focus on electromobility, electrification of virtually all ground transport. And it took a long time for the department to be persuaded by myself and my team and others that hydrogen had to be considered as part of the mix, not for necessarily for cars and small vans, but for larger vehicles, HGVs and buses in some cases, off-road vehicles, some trains, potentially quite a bit of maritime, and ultimately aviation could benefit from hydrogen. And so we collected a lot of data to show that. It was actually quite hard because although there's a lot of hydrogen industry in the UK, it was quite fragmented. We've got world leaders in designing electrolyzers, in designing fuel cells and the drives, for example, but wasn't really well joined up. And I think one of the challenges was, in 2009, 2010, there was this move in transport to move down electrification route. And there was a leap of faith there because the electricity generated in the UK was quite dirty, almost 1,000 grams of CO2 per kilowatt hour generated. The cost of 1 kilowatt hour of lithium ion battery storage, which are used in electric vehicles, was about $1,500 in 2009. So there's a real leap of faith that it could become a technology fit for purpose. But with the leadership from government, which meant the investors, the innovators, the venture capitalists went into the electromobility field, you're now seeing that 1 kilowatt hour of battery storage is less than $200. The electricity in the grid is less than 180 grams of CO2 per kilowatt hour. Hydrogen's at a cusp where I think it could do that. I think the innovation potential is there to really improve the efficiency and reduce the cost of everything. But unfortunately, government hasn't come out clearly to say hydrogen has a really role to play in transport, in big industrial processes, in homes, etc. And without that confidence from government making a bit more noise in that area, I think there is a reluctance to invest in all the aspects of hydrogen in a way that was done for transport, for electromobility 15 years ago. But I think we've got all the pieces there, and I feel it has a role to play. And also from a resilience point of view, having a number of different fuel vectors, energy vectors for transport, I think is actually a safe thing to do.